Hi everyone, this is Fahad Mirza and I welcome you to the channel. Since the release of DeepSeek R1 model from DeepSeek, GRPO is one thing which is gaining a lot of popularity. We already have covered this GRPO in detail on the channel, and we also looked at its practical applications and implementations. For the purpose of this video, I'm going to share with you this TinyGRPO, which is a watered down implementation in a very simple way of this amazing technology from DeepSeek R1. And not only I'm going to give you a hands-on demo, but before that, let's try to understand in very simple words what exactly this GRPO is and why we are using this TinyGRPO. So before that, let me set the stage. Let's go through some of the basic fundamental concepts in very simple words. First up, you need to know what is a pre-trained model or a base model. A base model is a model which is educated or trained on a vast amount of general data, typically collected from the internet. Pre-training usually involves a self-supervised learning method such as predicting hidden or masked words in sentences. Or in other words, it is an autoregressive model which predicts the next token on the basis of previous ones. After a model is pre-trained, it can understand and memorize general language patterns, grammar, syntax, and word knowledge. And these models are a powerful initialization that can later learn specific tasks with minimal additional data or tuning. And that is where the next phase comes in, which is called as instruction tuned model. An instruction tuned model is a specialized version of a pre-trained model that has been further fine-tuned to understand human instructions or commands clearly. These models develop the ability to recognize instructions like solve the following problem or explain to me about photosynthesis, something like that, and where they learn to respond strictly aligned with these instructions. And that is where the model become more usable and aligned with human directions. And then comes the reasoning models, just like OpenAI's GPT-4o or DeepSeek R1. A reasoning model is a model that shows capabilities beyond simple predictions or memorization. These models show deeper logical, mathematical, or problem solving abilities, often seen in tasks that require sequential steps of thought, planning, or multi step logic. For the reasoning models, there are various types of techniques that are used. For example, chain of thought, where model explicitly generate intermediate reasoning steps while arriving at answers. There could be self-consistency method, where models explore multiple potential reasoning paths before choosing an optimal solution. Third, we have reinforcement learning, where model progressively improves their reasoning and problem solving strategies based purely on reward from their responses without relying on large supervised data sets. So, now what is GRPO? GRPO is a specific or a type of reinforcement learning that is tailored for improved model reasoning without needing any costly supervised data set. Unlike methods requiring both policy models or any evaluating models, GRPO estimates its baseline for policy improvement directly from comparative rewarded outputs sampled from the current model itself, and that is why it is called as group relative. It simplifies training and drastically reduces computational requirements compared to traditional reinforcement learning methods. Now, we have this tiny GRPO, which even provides a simple memory efficient way to do the GRPO to train a model and then to test it. For example, in this video, we are going to show you how to use this tiny GRPO on a small model, and then we will see how it works. So for the model, I'm just going to use Quen 2.5 1.5 billion parameter instruct model from Alibaba, and then we are going to do GRPO on it with a very small GSM 8K math dataset. So let's get started. Before that, let me also give a huge shout out to Mass Compute who are sponsoring the VM and GPU for this video. This is a VM I'm going to use. Let me show you. So Ubuntu 22.04, and this is my GPU card, NVIDIA RTX A6000 with 48 GB of VRAM. Let me create a virtual environment with Conda. And if you're also looking to rent a GPU on very affordable prices, you can find the link to their website in video's description. And I will also give you a 50% discount coupon for range of GPU. So please do check them out. Okay, so my virtual environment is almost done. And now let me git clone the TinyGRPO repo. That is also done. And now let's set up the environment. For that, the good thing is that they have provided this setup.sh file. Let me quickly check it out. There you go. So this is set.sh. I'm just going to run it from the root of the repo here. And as soon as you run it, it is going to install a lot of things. So let's wait for it to get finished. And while it installs all the prerequisites, let me also give a huge shout out to our good friends at Camel AI who are sponsoring this video. Camel is an open source community focused on building multi-agent infrastructures for finding the scaling laws of agents with applications in data generation, task automation, and world simulation. And everything is installed. Let me clear the screen. Before I show you how to train and test this out, let me show you the code. So let me open it in VS Code. So this is the code which we need to use in order to use this TinyGRPO. As I said earlier, the primary focus of this TinyGRPO is to show you how to use this GRPO to train your own model by using this new technique. Now they have shared two scripts, train.py as you can see on the left to train the model, and test.py to test it out. So I'm not going to go in every line, but just to give you a rough idea what this train.py is doing, it is setting up a fine-tuning task using the GRPO algorithm on a reasoning dataset which is GSM8K, and GSM8K is a math reasoning task dataset. It loads a pre-trained and instruction-tuned model which is Quant 2.5 1.5 billion as I mentioned earlier, and then it conducts the initial reasoning evaluation for pre-GRPO accuracy. And then the main reinforcement learning training loop starts, which says train with GRPO. This is where the evaluation is being done. I'm just going to go down to show you. This is where main is starting and the main loop is happening. Now that main RL training loop trained with GRPO iteratively improves reasoning capabilities by optimizing policy outputs based purely on model generated output and rewards derived from automated evaluation metric, which is the extracted correctness of math solution. And if you want to see the code for train with GRPO, as you can see here, you can simply go to this grp.py, and they have shared all the code here, which is a bit of a low level. You don't really have to worry about it. This is just a implementation on the logit level and all that stuff. But if you're interested in learning more about logits and stuff, just search my channel. I have done various videos on it. And then once the training is done, there is a test.py which primarily again loads the previously GRPO enhanced reasoner model, and then it runs inference using new math and logic heavy prompts that clearly extracts reasoning outcome from the generated answers. And primarily this is showing you how the reasoning improved model performs and the details of logic step reasoning that traditional language models are not always successful at. So now you know which scripts we are going to run. So let's go back, and then let me clear the screen, and first let's run this train.py. And the first time when you will run it, it is going to download the model, which is just over 3 gig size, the Quant 2.5 one. So let's wait for it to get downloaded. And the model has been downloaded. It has also downloaded the dataset, which is a very small dataset. As you can see, it has split it into training and test, and it is in Parquet format. And now it is doing the evaluation on 30 samples, just to make it quick. And you can see that training is happening, and this is where the dataset include step-by-step information, you see. This is, sorry, I'm just taking you up. So you see, this is evaluation, this is a prompt. We are instructing model to respond in reasoning and slash reasoning and then give the answer. And that is how it is working. We have also given it the expected answer. And then this is a full generated response, step by step. This is a correct one, still hasn't got it. The model is training, going back to check if it is answer is correct or not. This is how the GRPO and this reasoning training works, where you give it a data set, it tries to generate the answer. If it does, it is rewarded. If not, then it goes back. There you go. So the whole reasoning step by step is happening. And it just makes a lot of iterations. And if you have ever gone on a dinner with any of your model trainer friend, you might have noticed that they keep looking at their phone just to check if the model, how the model training is going, if the loss is going up or down, because this is how they are just checking if the model is predicting the right answer. If it is, then the loss keeps going down, but then sometimes it just keeps going up and up, or it just becomes very static. That is when they just stop the training, remix the data set, then start it again. So it's a very, very highly iterative process. I was actually quite amused when someone asked on one of the videos how can they create your own JAMA model just yesterday. So look, this requires a lot of GPU grunt, a lot of data set iteration. It's not an easy task, and to be honest, not everyone is required to do this. This is just for the learning purposes, to see how this reasoning works and how the model performs. Other than that, really, I don't think so that other than these big labs, anyone really need to create the model from scratch. And by the way, if you are wondering how much GPU VRAM it is taking, so let me show you in real time. It is just consuming 3.5 gig of VRAM. It's a small model, and GRPO is very lightweight. It is quite good. Okay, so it is still going on. Anyway, so it is going to take few hours to finish because these training runs take long time. So you see that just in the last 30-40 minutes, it has just done 3 of the task out of 30. So it is going to take few hours. So I'm not going to wait that long. But other than that, you see that as the time will progress, this accuracy will improve a lot, and then you will see it is going to be, it won't be 100%, but it will be close enough to see that the model is now a reasoner model. And then you can use that test inference model to just do any inference you like. You can customize that script. So pretty good effort, I would say, if you are just after understanding how GRPO works and all that stuff. I will drop the link to it in video's description. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.